Okay students, let's start with the next chapter, that is the shear force and bending moment diagram, and that is the chapter 2 of the strength of materials which we are discussing. Okay, so to start with, we need to know what is actually shear force and bending moment. So everyone is confused that what is shear force and what is bending moment. So today we will discuss in depth that what actually shear force and bending moment are. So whenever there is a building or any system or any beam or any column, whatever it be, can you see shear force? Can you see the bending moment? I cannot see. Yes, I can see the live loads acting on the system. Yes, I can see the dead load. The dead load is nothing but the weight of the system. Can see it and it is acting, that is, it is actually having the dead load. But can you see shear forces, shear loads? Can you see the bending moments? No. Can you see the moments which are acting? Yes. Some loads which are there, live loads, they cause the moment also the system. But can I see bending moment? Can I see shear force? The answer is no. Why? Because these are simple internal forces of the system which cannot be seen. As I told you, can you see the joints in my body? The joint forces? No. Can you see? Yes, I am standing, my weight is there, I am standing on the ground, so there is the loading which I am giving on the ground, that is my dead load, and if someone is hitting me on the top, there is the live load on my body. But can you see my joint forces? No. Similarly, on a beam you cannot see the internal forces, you can only see the live loads and the dead loads, and the shear force and bending moments on the first priority is the net internal forces of the system. So I'll tell you what is actually shear force. So let's see what actually shear force is all about. Okay, so here we have a beam. Okay, we have a beam which is applying some load, okay, on the system. So let's call that the net load applied by the beam is W downwards. So it is applying net W load downwards on the system. Okay, so net, at the moment we do not know any supports or any something, just we know that this is a beam and this is applying a net downward load of W. So we know that this is a symmetric system, so there will be reaction. So this will be, we do not know any reaction. What is reaction? We don't know. We know that these are some loadings which have been given so that it is balanced. So that is nothing but the supports which we keep. So these are supports, we provide reactions to the system in order to balance the system. So the supports will be here and that will be nothing but symmetric. So this will be W by 2 and this will be W by 2. Very easily we can calculate because we know that net is W downwards, so we need W by 2 upwards. Okay, so what actually is shear force? Now shear force is not seen. When I can see the shear force is when I cut any particular section. So if I cut any section, for example, I cut this section over here. So I've cut this section and now I have taken this section out here. So what is happening is, so if I take this system, so let's take the system here only downwards. So we'll see that this is the section which I have taken out. Okay, and there is a W by 2 force over there. And then I've cut here, so this will be somewhat like that. And there is again W by 2 over here. Okay. So what is actually happening over here is, this beam will also be applying some amount of load. For example, I have cut it here. Let's suppose this is L by 3 and this is 2L by 3 where I have cut. Okay, so what will be happening is, this weight will be applied somewhat here. So this net loading will be applied somewhat here. So how much of this? This is L by 3. So this will be having 1/3 of the weight. You very well know this will be what? W by 3. So this W by 3 will be acting downwards. Okay, this W by 3 will be acting downwards. So this system, now this is a system. Now let's take it here. So this is a system which is having W by 2 load over here and W by 3 downwards. Okay. So can you see that the system is balanced? It should be in equilibrium, right? I've just cut the section, but every section in the system should be in equilibrium. But is it in equilibrium? No, I do not see that this is in equilibrium. So there might be some loading over here which has to be applied on this surface. Because we have cut, so there will be some surface forces. Whenever you cut something, there are some surface forces. So that surface force is what? This might be some P force which might be coming down, which should be applied downwards. And how will you calculate that P? That P, we can see that P should be applied down because W by 2 is greater. So P plus W by 3 should be equal to W by 2. So this P will be equal to W by 2 minus W by 3. So this will be what? W by 6. So this P is coming equal to W by 6. And what is this P? Is actually is hitting the surface. It's actually, this is a beam. So if you see the cross-sectional area, it will be like that. This will be something like this. So here, there is W by 3 of this W by 3 is coming downwards. And there is support which is coming as W by 2. And on this surface, you have downward shear. And this is nothing but the shear force, this now downward force which is coming. This is the P is equal to W by 3, which is coming on the section. If you cut the section, you'll see this W by 3 which is acting downwards. And that is what actually the shearing the surface out there. So now, if there is a P by W by 6 applied on that particular thing, so again, so here I know that there is some shear of the surface in downward direction, and that is equal to W by 6. So obviously, to balance that particular thing, when you combine both of these together, there should be one more loading. When you combine, there should be one more shear, and similarly, this will be 2W by 3 over here. Isn't it? This will be W by 3, so this will be what? 2W by 3. So there should be shear of this surface as well. Okay, so whenever there is system, there is a shear acting on the surface, then only you will get the net downward movement. So here, this will be what? 2W by 3, and this will be downward. So net 2W by 3 is downward. So now you know that net shear should come upwards here. So what will happen? If you cut the section, here also you will get the same value. That will be nothing but 2W by 3 minus W by 2, and that will be again W by 6, and this one will be in upward direction. So what is happening at this system, this section if I see, so what is happening here? There is some downward shear, and here it is upward shear. That is what is doing, that is having shear. The forces are shearing the surface. So that is what is causing the deformation of the system in this direction, and that can cause the failure of the system also if the shear force becomes a high value. So if the shear force increases to the shear limit of the system, so it will break that particular system, and we'll see that shear failure. In soil mechanics, the shear failure only causes the failure of the soil. Okay, so that is how you calculate this W by 6, and this is only what it is causing the shear of the system. Okay, so this was all about the shear forces. Next we will discuss what actually the bending moment is. Okay students, now let's discuss the bending moment, what actually the bending moment is. So here to discuss the bending moment, I have taken a concentrated load system. Here this is a weightless beam. So there a concentrated load of P is acting in the center. So what I am actually doing is, now again the concentrated P load is acting in the center, so their support reactions would be P by 2 and P by 2 generated. Okay, now we have a better knowledge about supports. So now we can say that there is P by 2 and P by 2 generated over here. Okay, so what I am seeing is, if at distance of L by 3 again, and this is 2L by 3. So if I cut the section, now what is happening is, if I see this section, this is P by 2. So you can see that there is no loading in between. This is this is your weightless bar. So again, now here directly you can see that what is the shear developed in the system. So the shear developed in the system will be downwards P by 2. Okay, very easy. Now, but do you think this is a balanced system? Last problems which I took was like this only, and there was a simple mistake I was doing which was not focused a little bit. But now, can you tell me what is the focus over here? What should be the focus? The focus is like here, the system is not in equilibrium. Why? Because this is in force equilibrium but not in moment equilibrium. Why? Because if I take the moment about this point, This P by 2 will pass and this will create a moment in this particular direction. So this will rotate the system. So that was in the last system which we took was in equilibrium, but every system is in moment equilibrium and in the force equilibrium as well. So here there should be some moment. This is causing by due to P by 2 into L by 3, their moment is acting. But to balance that moment, there should be a moment also given to the system. What will be that moment? This moment is given in this direction. This is causing clockwise. So to balance it, there should be a anti-clockwise moment. The magnitude will be, see here, this is causing P by 2 into L by 3. So to opposite of that should be there. So that will be what? P by 2 into L by 3 only, but in opposite direction. So what is it doing? It is actually doing this amount of moment is calculated in this particular direction. So that is nothing but the bending moment, which is the internal force or the internal moment of the system. So what actually it is doing? This is actually trying to bend the system. Like this is creating a bending moment like this, because this is creating moment like this in this point, and this is creating a this at this point. There is a very small and thin line between bending moment and moment. Bending moment is an internal force and moment is actually the net force into distance calculated at a particular point. Whenever there is a system, so moment at every point is 0. But bending moment at every point is not 0. There might be some amount of bending moment at any particular section. So if I cut one more part over here, list this one. So what will be there? There will be what? If I just take a very small system out there, so what will be that? That will be this much system, and there will be P by 2 here, and there will be P by 2 upward direction. So there is shearing of the system like this. This is the shearing of the system going like this. But here, as you can see that there is a P by 2 into L by 3. So again, to balance this out, you need a moment. This is P by 2 into L by 3. So what is happening? There is shearing of the system like this, up and this down. There is shearing of the system going on. So what is happening here? This section is being sheared in this way, and there is a bending moment like this created on the system. So this is bending this whole beam like this. Every section here, you will get this kind of bending, and that will cause the system, this will be bending like this. And that is called as the sagging bending moment. So the system is bending like this, and these two, as you can see that these two movements will cause the system to bend like this, and this is nothing but the bending moment. Okay, so bending moments are always occurring in couples. So both should be coupled, equal and opposite. So these are causing the bending of the system. What is moment? Moment I can calculate here, wherever. And wherever you calculate, the net moment at that particular point will be 0, because the system is not rotating. So the system is not rotating, the net summation m you can do at any point equal to 0. Similarly, at the system, you can do summation fx equal to 0, summation fy equal to 0, as this is in translation equilibrium also in vertical and horizontal directions. So that is nothing but the equilibrium conditions. But what is bending moment? Bending moment is something which occurs as a couple and tries to bend the system. And these are what? Internal forces. If I cut the section here and here, just to the right and the left, you can see that there are two couples generated, two shears generated. So these are causing shear in this direction. This section is getting sheared up and down like this. So this point tries to go up, and this point tries to come down. That's why there is shearing also, because one surface tries to go up and another tries to go down. So this is called shear. So this is why the failure of the surface tries to occur. And there can be shear as well as the bending failure of the system. Now if this bending stress or the bending strength of the system is less than the bending moment caused by P by 2 into L by 3, system will fail in bending. Similarly, it can fail in shear also, depending upon what is the shear capacity of the beam and what is the bending capacity of the beam. You will calculate the bending moment at every section, and you will check whether which is the maximum bending moment actuating in the particular beam. Then you will compare with that with the strength, and if that is less, then your system will fail. If that is more, your system will not fail. Okay, if your strength is more, the system will not fail. If your strength is less, the system will definitely fail. Lesser than what? The bending moment calculated over here. So here, so what we can do is we can calculate shears in all the sections. Calculate shears in all the sections throughout, and then we can draw the shear force diagram for that. We know the shear force value at every particular section. Out of these two, what will you write down? Shear force. You do not say that net force on the system is 0. Obviously, it is in equilibrium, it will be 0. But shear force is taken one of these. So if this at this section, what is the shear force? P by 2 you will say. What you will say as the net bending moment at this section? P by 2 into L by 3, that is PL by 6. So that is how you say as the bending moment and shear force if asked. That what at this section, what is the shear force? At this section, what is the bending moment? That is how you say that this at this section, this is the bending moment, and at this section, this is the shear force. So similarly, you can calculate this throughout the length of the beam, and you can draw the shear force diagram and the bending moment diagram depending upon the situations and the loadings given in the system.